I need to introduce a concept by the name of SIRI. Now, it's got nothing to do with the thing on your wrist or the thing on your phone for the Apple people in the room. SIRI is actually an international standard that's come out of Europe. It's the international standard, which is the standard interface for real-time information. Extremely dry. But what it's about is defining a common standard and a common structure for messaging for passenger and particularly public transport service provision, so that all service providers throughout a jurisdiction can communicate and update status of their services and so on in a common format such that when they are all integrated, all services can be at least interpreted and understood en masse. So how did we do this? So what we've done is, I'm showing you a fairly simplistic diagram here, which is showing you an amalgam of a series of data points or data sources that are coming together. So we're pulling live data, and when I say live, I mean to the second data feeds off the train management system and off the signalling systems to understand what the trains are doing, where they are, the speed, the location, direction of travel, and a whole host of other data points that are coming through in real time. These are individual data points streaming into the platform. We also have facilities live data as well, so the status of all the vertical transports, shutter doors, car park facilities, toilet availability, and so on. Along with a whole host of other static data points. So there's a whole host of sources such as your schedules, all of the reference data associated with your network, all of the facilities reference data, and so on. So what's happening now is that's being streamed into what we call the SIRI processing engine. So what that engine does is it intercepts all of that data and builds out a whole series of messages to understand where the train is at relative to its schedule. So i.e. it snaps to a schedule to understand where it is relative to where it should be. And in the event that there's any disruptions or delays, so the delays that Stephen was just talking about, the system can automatically recalculate its position and understanding of where that train is relative to where it should be. And what it's doing then is it's transmitting, using the SIRI protocol, down to the multimodal data integration service, which is managed by Transport New South Wales, to provide real-time updates on where that service is relative to the schedule. What that then allows the downstream applications to do is that they can subscribe to that service to understand where are the trains or where are the services relative to where they should be. So that's things like Google Maps and all of the trip planner technologies and so on that are going on out there. So again, this is all in real time. And in fact, we're getting to the point now where we're able to, from time of receipt of message from the train or the signalling system, within 1 to 2 seconds, we can recalculate the position of that train relative to where it should be and recommunicate all of that updated information down to the end platforms. So that's from the perspective of customer or passenger updates. But what about operations as well? So by virtue of ingesting all of this data in real time, we're now also able to make that data available to the... So we've a couple of good examples here that we're showing is, and I'm hoping that's actually playing, yes it is. So what you're seeing here is in fact a screen recording of the real-time, a couple of real-time services that we provide. In the top left corner there you're seeing a train graph, and I'm sure I don't need to tell anyone in the room what a train graph is. And similarly a real-time map showing the location of the various rolling stock. So what you're seeing here is in real time, true real time, the operators are able to see in interfaces that are very familiar to them exactly how their services are performing relative to the expected schedules and service delivery obligations that they have. And when interruptions or disruptions occur, we can see immediately the impact of that. It's not the next day type view. We can see immediately in interfaces that are very familiar to them to understand those interruptions and the impacts of them. So how do they use that? Well, a classic example would be in terms of incident recovery management, for example. So where we have a primary interruption, this is the sort of thing you would typically see as a post-interruption event or post-interruption review. We can see in real time now that initial impact or that primary impact of the incident or the disruption. And we can now, the operators can now use that real-time information for then recovering to make sure that, look, yes, we acknowledge that disruptions occur, but it's how do we recover it? How do we make sure that we minimise the impact on our passengers? So that's giving them that real-time feedback as they're making decisions, making service adjustments and so on. How does that play back to them so they can keep fine-tuning all of that operational adjustments and so on? Thirdly, from an operational perspective, as Stephen briefly mentioned, as services are being disrupted and necessarily changing, the system can automatically recalculate all the various downstream messaging, which would include timetable adjustments as well. So again, the downstream applications can be absolutely updated and understood as to where we're up to.